Hello again, this is Miss Nakayama, and today's lesson is 3.4b, Logarithmic Equations. So we are going to solve log equations, and there are two methods that you can use. One is using the definition of a log, the other one is using the one-to-one property, and then we're going to solve some applied problems, which of course are word problems. Okay, so first and foremost, using the definition of a log, okay? First off, when you do that, you're going to express your equation as the log, the log on one side and the number on the other. Okay. Then, excuse me, applying the definition, we have the log base b of m equals c if b to the c equals m. This is that little kick out that we keep talking about. B raised to the c equals m. That's what's going on in this case. Then you're going to solve for the variable. And most importantly, this is something that is different and more crucial than what we did in the previous lesson of solving exponential equations. And that is, you need to check your solutions in the original equation every single time. Because you got to remember that m has to be greater than 0. And you're like, well, what is m? Well, remember that the domain of your log function is 0 to infinity. Or what you have to remember when you check these things is you cannot take the log of a negative number. That's what you need to remember if you get anything out of this lesson, this chapter with logs and solving equations. You cannot take the log of a negative number. That doesn't mean your answers won't be negative sometimes. You just have to check them. So you're going to watch as we go through. So first off, solving this equation, log base 2 of x minus 4 equals 3. So our definition, log base b of x equals y, if and only if b to the y equals x. So to apply that to this problem, that means 2 raised to the third power equals x minus 4. That's what I just said. And of course, 2 to the third is 8. So we have 8 equals x minus 4, and x equals 12. Now, we got to go down and check that. So when I do, I'm going back to my original equation, and for x, I'm putting in 12. And when I do, and y'all put this left side into your calculator. It's helpful to know how to use your calculator to check these things. But when you do, you find out that it checks. Now, I have taught this for a long time, and I have taught this method, but a couple of years back, I started really concentrating on the fact that logs and the exponential function and the logarithmic function are inverses of each other. So they undo each other. So I want to talk to you about another way of solving this problem. Log base 2 of x minus 4 equals 3. So when we did the exponential equations before, when we couldn't rewrite it as a common base, we took the log of both sides. Exponential, how do I undo the exponential? I take the log. Well, now I have the log, and how do I undo the log is make it exponential. So if I do and make these exponents of the same base, the base I'm going to use is whatever the base of my original problem is. So I'm going to go what you call exponentiate both sides. And when you do that, okay, nope, not that one, this one. This right here, those are composing the inverse functions that I keep telling you about. So that means on the left side, I have x minus 4, and on the right side is 2 to the third, which is 8. And that, of course, gives us the same answer. When I started solving these type of equations and telling the students to do this, I've had more success with students getting problems correct because they always forget this. So that's what I'm going to concentrate on the rest of the video, solving them in this manner so you can see it. Probably different from the way the examples are in My Lab Math. Choose whichever one works for you. Obviously, what's most important is for you to get the problems correct. All right, but here's the next one. Okay. Solve 4 times ln of 3x equals 8. Okay. Regardless of what method you choose, you always have to make sure there's no coefficient on your log function. So the first thing we're going to do is to divide both sides by 4. And when we do that, I'm going to get ln of 3x equals 2. It does simplify the process. So when you exponentiate, because this is the log, so to undo the log, I'm going to use exponents. And when you do that, you got to know what the base is. So what is the base of this function, ln? Well, the base of ln is e. So I'm going to exponentiate with a base of e. And when you do, these are inverses of each other. It's really important for you to see that. So e to the ln of 3x equals 3x. And then I have e squared on the right side. And you've got to get an exact answer oftentimes in MyLab Math. So divide both sides by 3, and that just gives you x equals e squared divided by 3. I think it also asks you for a decimal value. So you put that in your calculator and you get 2.46. But let me tell you something about checking it. When you check it here, y'all, again, the original problem, but if you will do this immediately after plugging in right here. So after you have gone from here to here and plugged into your calculator and you get this decimal that I have rounded to write on the video, when you check it in the original problem, use the answer button on your calculator. And when you do, you put 4ln parentheses 3 times answer close parentheses and hit equal. It will tell you 8, so you know that you've got the right answer. There's no rounding or anything of that sort. Okay, those were pretty straight up. Look at this one. So the difference in this problem and the last problem is I have more than one log in the original problem. I have the log of x plus the log of x minus 3 is equal to 1. So this is where your properties are going to come in important, okay, are very important to remember, because you have to have a single log on that side of the equation. You can't do it until you do. So how do I bring together addition? Well, hope you remember that that's going to be multiplication. So this is going to be x. I'm going to multiply my two arguments. So I multiplied x and x minus 3, and that equals 1. Again, now I'm ready. I have a single log with no coefficient. So I'm going to exponentiate. And what is the base of that log? Well, if there's nothing written there, we know it's a 10. So I'm going to exponentiate with a 10. And I'm going to see that these are inverses. So on the left side, I'm going to get x times x minus 3, which is x squared minus 3x. And on the right side, I get 10 to the first, which is 10. Then we bring everything to one side. We factor to find the factors of 10 that subtract to give me 3, 5, and 2, negative 5 and 2. So x equals 5, or set each factor equal to 0 first. So we have x equals 5, or we have x equals negative 2. So I got to go check. Very, very important. All right, so again, I'm plugging into the original problem. And I just started with the first expression, and that's taking log of negative 2. I can't do that. I cannot take the log of a negative number, so negative 2 doesn't work. All right, but I still have to check 5. So when I put log of 5 plus the log of 5 minus 3 in my calculator, I check it, and I find out that it worked. So the only answer to this problem is x equals 5. Important to check. Okay, so the other type of problem that you will have is one that deals with the one-to-one property, and that is having the log of 1 equal to the log of a number. Okay, again, you have to make sure your coefficient is 1 every time. You don't want to do this until there's no coefficient on either side in front of the log. Okay, so if that's the case, and the log base b of m equals the log base b of n, then we can set the arguments equal to each other, and that is m is equal to n. Then we're going to solve for the variable, and again check, make sure that neither m nor n is negative or 0. It can't be 0. Why? You cannot take the log of a negative number or 0. Okay, so look at this example. Well, that's fine. We'll leave it there. All right, so we have ln of, I don't know why I did that, ln of x minus 3 equals ln of 7x minus 23 minus ln of x plus 1. So again, I have more than 2. Because I can have 2, I could have 1 on each side, or I could have just 1. But I can't have 3. That means I got to bring these 2 together. And that minus sign, I hope that reminds you that that means I can bring these 2 together with division. So ln of x minus 3 is equal to ln of 7x minus 23 over x plus 1. So if you think about ln of x minus 3 being over 1, then those 2 arguments are equal to each other. This right here has to equal this right here. So I'm going to cross multiply. X minus 3 times x plus 1 is equal to 7x minus 23. Then I'm going to FOIL equal to 7x minus 23, and I'm going to bring everything to one side because it's a quadratic. The factors of 20 that add up to 9 are minus 5 and minus 4. So I set each factor equal to 0 and x equals 5 or 4. So I'm going to check. Don't know why that happened. So always check in the original problem, y'all. So that means first I'm going to plug in 5 everywhere I have an x. Okay? And basically, you can simplify it here if you want to. So that's ln of 2 equals ln of 12 minus ln of 6. You can plug it into your calculator individually, each side individually, and see if you get the same number. But in this case, you do. So 5 checks. Got to go check 4. So when I go plug in 4, I'm going to have 4 minus 3, 7 times 4, and 4 plus 1. Okay? And I simplify each of the things in parentheses because I'm trying to make sure I'm not taking the log of a negative number. And in this case, again, it checks out. So in this case, we actually have 2 possible answers. All right, look at this one, and then we have a word problem, and then we're done. Log of 2x minus 6 equals the log of x plus 3 plus the log of 3. Again, I have 3 logs in this question, so I got to bring this side together somehow. That's what that plus sign is reminding you, that when I have a plus, I bring it together with multiplication. So the log of 2x minus 6 equals the log of 3. I write the 3 first, doesn't matter which side, times x plus 3. So again, I have the same, I have a log equal to a log. So I'm going to set these 2 things equal to each other. I get to drop the logs if you want to think of it like that. And 2x minus 6 equals 3x plus 9. And that makes x equal to negative 15. So always have to check. So when I go check, I'm putting in, I started on the left side. When I put negative 15 in right there, y'all, that's negative 30 minus 6. Nope, can't do that. Cannot take the log of a negative number. So in this case, the answer is no solution. All right, last problem. We got a word problem. You have a few of those in your assignment. The percentage of adult height attained by a girl who is X years old can be modeled by the function. So we have this lovely function here, okay? And again, remember, I'm telling you, pay attention to the labels that go with each variable. So X represents the years, her age, and f of x represents the percentage, okay? F of x being your y. So in this particular case, at what age, that means they're asking me for X, has a girl attained a 97%? That's the Y value. So that means 97 is going to be put into the formula up there on the left side. So I'm going to have 97. Well, oh, Pooh Bear, that's not what I wanted to do. Go here. Oops. 97 equals 62 plus 35 times the log of x minus 4. I plugged in 97 because it's a percentage. Don't need to change it. Okay. 62 plus 35 times the log of x minus 4. So to remind you, I got to get that log by itself. So the first thing I'm doing is subtracting 62 from both sides. And then I got to get rid of the coefficient. Okay. I can't use any of those methods we have of solving until that is 1. So I'm going to divide both sides by 35. And when I do, that's gone. 35 divided by 35 is 1. And now I have a log. And how do I undo the log? is to exponentiate. And what is my base? It's not written there. If it's not written there, my base is 10. So I'm going to exponentiate with 10. These are composing inverses. So 10 to the first power equals x minus 4. I add x to both sides. So the answer to my question is about at age 14. And that is all we have. So if you don't get anything from this, y'all, please, exponential and logarithmic functions, how are they related? They are inverses of each other and they undo each other. I hope you enjoyed watching. Thank you so much for watching. Y'all have a great day.